On October 29, 2025, interstellar visitor 3I, Atlas reached its closest point to the Sun, and what happened next stunned scientists across the world. Instead of fading, as most comets do when they approach intense heat, Atlas erupted in brightness, shining far beyond prediction. At the same time, the far side of the Sun was exploding with massive coronal mass ejections, billion-ton waves of plasma and magnetic energy hurling through space. The coincidence was too precise to ignore. As Atlas blazed brighter than any comet its size should, the Sun was in chaos, and experts began asking a dangerous question. Had something out there, or in here, change? At its perihelion distance of 1.36 astronomical units, Atlas should have experienced about half the solar energy Earth receives, enough to cause predictable sublimation, releasing jets of gas and dust. But instead of a modest glow, its brightness surged nearly 300 times over just a few days. That spike made no sense under normal thermal models. Something external was feeding the outburst. As the Sun's backside erupted, data from SOHO and Stereo revealed that several of those CMEs had crossed Atlas's orbital path. That meant the object was directly struck by solar plasma just as it reached maximum heat. Those 10 days between October 19 and 29 formed one of the most violent solar sequences in recent years. Multiple CMEs left the Sun at speeds exceeding 1,200 km per second, sweeping up the solar wind into powerful shock fronts. When Atlas passed through that torrent, it entered a storm of high-energy particles, radiation, and electromagnetic turbulence. Under such conditions, ordinary comets would fragment or disintegrate. Atlas did not, it flared. Photometric readings from SOHO's coronagraphs showed a brightness curve steep enough to defy expectations, following an R-carat 7.5 power law, more than double the rate typical for Oort cloud comets. In blue and orange filter bands, emissions from carbon and nitrogen molecules spiked sharply, suggesting violent chemical excitation. But the most telling clue came from the comet's shape. Instead of forming a smooth coma and straight tail, Atlas developed an uneven, asymmetric glow. One side burned brighter than the other, hinting at directional ejection or even plasma-induced jets. Its tail was faint, fragmented, and oddly curved, almost as if being twisted by magnetic fields instead of solar wind alone. For days, teams across NASA and ESA scrambled to verify the orbit. Despite the chaos, the comet's trajectory never changed. The JPL ephemeris confirmed that Atlas stayed perfectly on its hyperbolic path, an interstellar visitor continuing outward, not a body captured or deflected by the Sun. That stability meant whatever energy hit it did not alter its course. But something about its composition, its structure, or its reaction to plasma made it behave unlike any comet ever observed. Citizen scientists joined in, stacking hundreds of frames from SOHO and Stereo data to track the faint glow buried in the solar haze. Their combined efforts revealed that the outburst wasn't a brief flare but a sustained, evolving event, one driven by conditions beyond mere sunlight. Plasma physicists proposed that the CME impacts had triggered sputtering, a violent stripping of surface molecules by charged particles. That process, coupled with the intense ultraviolet radiation, could explain the rapid rise in brightness and the comet's strange asymmetric form. It wasn't melting from heat, it was being sculpted by the Sun's magnetic fury. Now, as Atlas recedes toward the outer system, a new danger builds closer to home. Those same active solar regions that bombarded the comet are rotating toward Earth. Over the next week, forecasters warn of direct geomagnetic impacts. Early signs are already visible. G1 and G2 level storms ripple through Earth's magnetosphere, airlines reroute polar flights, and satellite controllers brace for drag spikes. The last time solar conditions like this aligned was in 2003, the infamous Halloween storms that caused blackouts and satellite failures. Power grid operators across North America and Europe are now on alert, monitoring transformers for geomagnetically induced currents. The irony is chilling. Humanity's most distant interstellar messenger may have just offered a warning, not from deep space, but from our own star. As 3I, Atlas fades, its lessons remain luminous. The real danger isn't always the visitor from beyond, but the volatile heart of the system that sustains us. The sun's fury reminds us that in a universe filled with mysteries, the most powerful force of all is still the one blazing above our heads.